Hello, my name is Mohan Kumar. I'm a fellow at Intel Corporation, and I lead cloud architecture in the data center group. And I'm here to talk to you about continued Intel innovations in cloud and edge. With that in mind, I'll talk to you a little bit about how key role that OCP plays for cloud. And I'll talk to you about some of the joint innovations that we have going on with our cloud partners and with OCP in terms of innovations that we want to bring to the cloud and edge. And I'll conclude with a call to action. So before we get into the details, we need to talk about the why we want to focus on cloud. Public cloud continues to grow at a tremendous pace. By the year 2022, which is only 2 years from now, e-commerce will be at a 5.7 trillion revenue. Digital advertising is a $500 billion revenue, and the cloud services are another $500 billion in revenue. All of this means there are demand for servers and storage and network. And all the things that OCP focuses on are going to be very vital to the growth of this industry and for our well-being. So it's key that we want to focus on this very vital sector. And how do we go do that, right? It's not just about hardware. Cloud requires both hardware and solutions. So let's look at what our requirements are and how OCP projects are positioned against that. So cloud, of course, requires the bare hardware platform. And that maps to the work that's being done in OCP on server storage and networking. Cloud requires a platform to have security, and that maps into the security project of OCP. Security is very vital to the cloud because the customers, the tenants that run on the cloud need to know that they are protected from the other tenants that run on the cloud as well as from the cloud itself. Right? That's very vital to the long-term growth and sustainability of the cloud, is to have that confidential computing in there. And we need to also know that each of the portions of firmware that run in this environment is secure and verifiable to a source. And open system firmware is solving the security problem and also improving the cloud to a place where this firmware is visible, auditable, and we can improve the performance of this firmware to a point where it improves the overall efficiency of the cloud. Remember, in cloud, we're not talking about one system or even 1,000 systems. We're talking about millions of systems. So any improvement we make has a magnification factor associated with it. Management of these platforms, especially at this kind of scale, is key in the public cloud. With edge, it even becomes even more important because you don't have immediate access to the edge environment. They're off the roadside somewhere. So being able to remote manage the system is key. So again, OCP's hardware management project is well positioned. And despite the name, they are actually expanding from hardware management to cover firmware and other aspects of the management, which is heartening to see. And all of this is put together in a rack. And that rack has power and thermal requirements. And again, OCP's rack and power project essentially is well matched with that. And lastly, at a data center level, these things are all, at least for the public cloud, these things sit in a giant building somewhere. And there are unique data center facility related issues that we need to go solve. And OCP's data center facility project is, again, well matched to solve this problem. So overall, every aspect of building a cloud solution has got a matching OCP project underway and a place for us to participate, contribute, and collaborate with the rest of the industry to make cloud successful. Now, I want to talk to you about a few of these projects that we've been actively working on. First one that I want to talk to you about is the firmware support package and core boot. Right? Historically, for the last 20 plus years, the boot has been through a mechanism called UEFI. It's a piece of monolithic code that you get, and you essentially use that to from this point the processor comes alive to the point your OS is up and running is one monolithic piece of code that's provided to you. So there has been movement in the industry to break it into portions where we provide the code that just does the initialization of the processor and memory, and everything else is done through multiple options, whether it's core boot or Linux boot or multiple bootloader options. And that we are making possible through Intel's firmware support package, or FSP, and that allows you to boot your platform using Linux or any other OS as your option, as opposed to being confined to what was there in the last 20 years. This allows you to speed up your boot process. This allows you to open up your firmware so you have visibility. And this is a project that we are undertaking in partnership with Facebook in the OSF, or the Open System Firmware at OCP. And cloud, as I mentioned earlier, is about managing millions of systems, and at that kind of scale, things that are, if you have a probability of a very small probability of a failure that gets magnified when you have a million of them. Same thing applies to being able to update firmware, software, even things like track errors, right? They're very critical. When an error happens, you need to know, what does that error mean to me in a meaningful fashion? Now, if you don't know that, you're going to end up with outages in your environment that you need to, that you can resolve quickly and get back to healthy state. With that in mind, one of the things that we are working with OCP is to essentially do the error log standardization. As I had mentioned earlier, we have moving hardware management at OCP from not just hardware, focusing on just hardware, to focusing on hardware and firmware. But one of the key portions of that is clouds. At the scale of millions of servers, you're not sourcing from a single vendor, you're sourcing from multiple vendors. So it's very critical that the way they report errors across those multiple vendors is the same. So your ability to root cause and diagnose and fix the problem and move on is minimized, right? And with that in mind, we're going to work towards driving this common standardization for error logs across the servers that are supported by the OCP hardware management work group. The second topic I want to talk to you about is about liquid cooling. So as the processor power and the platform power increases and the power density in a rack increases, we're going to be challenged in the future to use the same air cooling solutions that have supported us for the last 20 years. And with that in mind, people have been exploring liquid cooling and liquid assisted cooling solutions. One of the key problems with liquid assisted or liquid based cooling is that any type of liquid and electricity do not mix, and any kind of liquid and electronics do not mix. So it's very critical for us, for the success of this project, to be able to detect a leak and be able to notify it immediately for this to be broadly used. With that in mind, Intel has partnered with JD to develop a leak detection solution, essentially underneath the pipes that carry the liquid, whether it's water or any other liquid. We have the traces that when they detect a leak, will notify the management circuit, and thereby you get notification instantly that there is a leak in progress. And we are working on a white paper for OCP on this topic. The next topic I want to talk to you about, so far the discussion has been on the public cloud infrastructure. Equally important is the emerging edge servers that are gaining prominence because of things like 5G and autonomous driving and various smart cities and so on, that driving the need for that. A lot of the infrastructure that has existed so far is focused on ruggedized one socket servers, what we call the efficient edge server. Those are typically based on Broadwell-based solutions. But there is a need for performance at these cloud servers as the usages grow, because you may be doing inference on multiple images. You may be doing, you're doing more beefier stuff in these environments, which means you need to have a focus on performance. So we're looking at Xeon SP-based solutions that have Intel's deep learning boost technologies to be able to take advantage of the AI capabilities that the processor brings and pair it with an edge solution to support these emerging usages in the edge space. Now, last year at the OCP forum, we talked about another key issue in the cloud environment, which is reduce the variability in performance. And the variance in performance comes from having platform firmware get triggered and then it takes time away from your operating workload. In order to resolve that problem, we have worked together to essentially come up with a solution called platform runtime mechanism that allows an auditable solution that you can use, and that also does not drop into this system management mode and thereby cause performance variability for the cloud platform. And we are happy to report that not only did we submit the case study, but the code that supports the drivers that go along with it and the sample handlers have been now uploaded into GitHub. And we've also been working on power management, which is another key aspect of cloud. And rather than me tell you about power management, I want to invite Justin Song, the Chief Power Architect of Alibaba, to talk to you about the innovations that we're doing together between Intel and Ali on the power management side.
Thank you, Mohan. I'm Justin Song. It's really good to be here. I'm leading Alibaba Cloud Elastic Compute Infrastructure Architecture team. Here I'm going to share our experience how to use Intel the technology to power management. On the slide, you can see our S-Dragon architecture is announced last year on Alibaba Cloud Conference. The S-Dragon architecture is a disaggregated architecture. We use MOC card to do virtualization and overlay network and storage offloading. The disaggregation architecture really helps reduce the virtualization overhead. Then we can sell all the compute to customer, and also we can evolve independently on network the storage. And in the MOC card, there is one important element called AI Ops. That's where our power management is running in. Today I'm going to show you how we use the AI Ops power management to increase availability and also to use power management to do performance management. Going to next slide, you can see on the left-hand side is interface to Power Master. Here we mean Power Master. We have a distributed power management platform, and we have Power Master deployed for region and for AZ. And we run Power Master to manage hundreds of thousands Intel servers. And Power Master talks to S-Dragon Power Agent. The Power Agent running on every S-Dragon server. And to increase availability and also to reduce the overhead to do power management on the host, we use both in-band tapping and also out-band tapping sub-agent. Unless very necessary, we use out-band tapping sub-agent. Then that means we go through the OOB sub-agent, EMC, and the ME panel to manage Intel CPU, EDR, display, storage, network, all of that element manage power. However, whenever there is a failure or denial of service in BMC, the BMC today still runs of legacy IPMI interface. Also, the processor inside the BMC is kind of weak. It cannot respond to high volume or high frequency power management requests. If that happens, then we need to open the in-band channel. The in-band tapping channel will call the virtualization layer running on the host. Then it can do necessary power management and also performance. Using this way, we increase the availability and the serviceability of the power management, and also we minimize power management overhead. On the right-hand side, you can see three pictures. The top one is the way how we manage power, how we do power tapping. There are several thresholds. For example, if we are almost 120% of the code of the rack server, then we are going to start our power tapping. And on the two pictures below, you can see these are two real examples. The picture in the middle shows an example when we started power tapping. We found the wireless performance requirement. Then our power master and the power agent will stop our capping and restore frequency and other frequency configuration right away to avoid further impact on performance. And the other bottom picture shows AC is okay to continue to lower power, but it may very quickly we use out-of-band and the in-band method to get power. And in sum, Alibaba and Intel will continue innovation on cloud platform efficiency. And we have a joint white paper. Right now is working in progress. Thank you.
Thank you, Justin. And now I'd like to conclude with a call to action. I talked to you about various initiatives that we have underway and innovations that we have underway in partnership with our cloud customers for the benefit of the OCP. I talked to you about how we are influencing the direction of firmware through Intel firmware support package and through Intel's platform runtime mechanism. I also talked to you about some of the stuff that we're doing for the data center facility in terms of being able to support liquid cooling solutions that are very critical going into the future. And Justin talked to you about what we're doing together on the power management to improve power management solutions on Intel-based servers. And we also talked to you about some of the hardware management and how the scope of the hardware management needs to change to include firmware and standardization of errors and so on. So there is a lot of great work going into OCP to expand the scope of the solutions for the larger benefit of the community. And we encourage you to take advantage of the Intel platform and the solutions and our contributions to OCP. We also encourage you to come participate with us and contribute to OCP on these projects, whether it's server, whether it's networking, storage, management, open source system firmware, or data center solutions and security. And there are multiple sessions that target deeper into these topics from Intel, and I encourage you to also listen to those sessions. Thank you.